Question number 18. A sphere is placed rotating with its center initially at rest in a corner as shown in the figure A and B. Coefficient of friction between all the surfaces and the sphere is 1/3. Then find the ratio of friction force Fa by Fb forces by the ground in situation A and B is. The option 1 is your 1. Option 2 is 9/10, option 3 is 10/9 and option 4 is none of these. Okay, now see the solution here. In this there are two situations are given. This is the situation number A. In this situation, a sphere is rotating in anti-clockwise direction. While in situation B, this is another situation. In this situation, a sphere is rotating in the clockwise direction like this. Now, if we are making FVD in these two situations, see, this point of contact have tendency to go in that side. Here friction your Fa in this direction, and this point of contact have going in this side. So here friction your F dash in this direction. Another forces are normal force and mg. Similarly, if we are looking here, the point of contact have velocity this, the friction force your Fb in this direction, and this point is going up, then friction force your F double dash in this side, normal force N dash and weight. So first of all, when we are talking about the friction force value, and from this side one normal your N1, and from this side another normal your N2. Now see the equation for A and B separately. See, N1 is your F into A because there is no motion in the horizontal side, and Fa is your mu into N. And another equation for vertical direction, N plus F dash upward direction and downward your mg, and fourth equation here F dash is equal to mu into N1. These are the four equations we are getting. Now we would like to find the Fa value. Fa is your mu into N, and how we can get the value of mu? See, let this your first, second, third and fourth equation. From this, F dash value we can put from here to this. See here, N, F dash your mu N1 is mg. Now N1 is your Fa again, mu, N1 your Fa, Fa your mu N again. So this will be your, this will be mu, N1 your Fa, Fa your mu into N. So we can have mu is equal, mu 1 plus mu square into N, the mu square plus 1 into N is equal to your mg. Then see the value of Fa. Then Fa is equal to mu into N, mu into N is your mg by mu square plus 1. This is the Fa value we are getting. Now see the second diagram. In this our equations, N2 you're in this direction acting. So FB you're in this direction. See, here as it is rotating your anti-clockwise FB that, then it will leave the contact. So N2 will be 0 here. N2 will be 0. So now N dash, so FB. FB is equal to your mu into N dash, and N dash is your mg, because N dash is equal to mg. As soon as N2 0, that gives us F double dash is also 0. So FB we are getting mu mg. Now we have to find the ratio of FA by FB. So FA by FB, FA by FB, mu mg or FB 1 by mu square plus 1, 1 by mu value given 1 by 3, 1 by 9 plus 1. So this is your 9 by 10. So this is our correct option. So answer 2 is the correct. So hence answer number 2 is the correct answer. Question number 19. It is given as a wheel is rolling without slipping towards right on a horizontal surface with a linear velocity v0. Then the velocity of a point towards right whose height is equal to the radius of the wheel is: first option your v, second option your 2v, third option your root 2v, and the fourth option v by 2. See, as per the question here, this wheel is given and this wheel is rolling with velocity of center of mass your v. If it is rolling, so it also have some angular velocity, and if r is the radius of that, so for rolling v must be equal to r omega. Now they are asking the velocity of the point which is at height at, and that point is your left side of the center, this point. So this point, because of the omega 1, it has tangential velocity r omega v tangential. Another, due to translational, it have velocity or v. And since v and r omega are equal in magnitude, so this point have two velocity, one v, another v. The resultant velocity of this point is your root 2v. So this point have resultant velocity root 2v. So correct option is your option number 3. So answer is your option number 3 is the correct option. Question 20 is given as a wheel of radius 1 meter is rotating with angular velocity 5 radian per second, is also moving forward with a velocity 4 meter per second on a horizontal table. Find the velocity of the slipping point. So first option your 2 meter per second, second option minus 1 meter per second, third option 3 meter per second, and fourth option it is 0. See the solution. This is given as a wheel. This is your wheel, and this wheel have radius your 1 meter and angular velocity your 5 radian per second. So radius your 1 meter, angular velocity 5 radian per second, and its velocity, forward velocity. This velocity is given here 4 meter per second. So if this is the v, so omega is your in this direction. So now they are asking find the velocity of slipping. Velocity of slipping means the point which is going to slip. It means point of contact. So this is the point of contact. This point have one velocity or tangential, in this direction, another your translational in this direction. The V tangential is given as r omega, r is your 1, omega your 5 meter per second. So tangential velocity, this is your 5 here, this is your 4. The net velocity in this side your 1 meter per second, and this is your opposite to forward motion. So this will be your minus 1 meter per second. So correct answer your option number 2 is the correct option. So answer is your minus 1 meter per second. Now come to the question number 21. A solid spherical ball rolls on a table without slipping. So what fraction of its total kinetic energy is associated with the rotational? So option number 1 is 1 by 7, option number 2, 2 by 7, option number 3, 3 by 7, option number 4, 4 by 7. See the solution of this problem. In this question they are saying this is the sphere, it rolls. So it has there two type of kinetic energy, rotational kinetic energy and translational kinetic energy. But in the question they are asking what is the ratio of rotational kinetic energy in Kr by total kinetic energy in Kr plus K translational. So in case of rolling, first of all, for rolling V is equal to R omega. So rotational kinetic energy half I omega square and half I omega square plus half mv square, as half I omega square means I is your 2 by 5 mr square omega square, 2 by 5 mr square omega square plus mv square. So here r square omega square your v square, so mv square mv square mv square cancel. So 2 by 5 plus 1. So this is your 7 by 5, 2 by 5 by 7 by 5. Finally answer is your 2 by 7. So our correct option is your option number 2 is the correct option. Question number 22. The question is given as a solid ball starts from rest and rolls a 30-degree inclined plane. How much time would it take to cover 7 meter? So option number 1 is 1 second, option number 2, 2 second, option number 3, 3 second, and option number 4, 4 second. Now see the solution, how to solve this one. Now the inclined plane of inclination 30 degrees given. See, this is the inclined plane and solid ball. This is a solid ball. So as soon as it start moving under the effect of gravitational force, so here friction force start acting. So we are resolving the forces mg sin theta, normal, mg cos theta. Under the effect of mg sin theta and friction, it will provide translational acceleration, which we want m into a. First equation. F will provide, friction force will provide a torque, F into R I alpha. So F into R, I is your 2 by 5 mr square into alpha. F is equal to 2 by 5 m, R alpha your 8 tangential. For rolling A is equal to here A tangential. So A is this. So M into A, so we can write friction force value from equation 1, 2 and 3. mg sin theta is equal to your ma plus f, 2 by 5 ma, 7 by 5 ma is mg sin theta. So A is equal to your 5g sin theta by 7, 5g sin theta by 7, and theta is equal to your 30 degree. So sin theta your 1 by 2, g is your 10. So this will be your 25 by 7 meter per second square. This is the acceleration of the particle. Now, if this has to travel a distance here 7 meter, then they require the time. The S is equal to ut plus half at square. S is 7, initial velocity is 0, half, A is 25 by 7 into t square. Now check it this one. So t square is your t square 2 into 49 by 25, then t is equal to your 7 root 2 by 5, and root 2 value 1.4, so 1.4 into 7, 7 into 1.4 by 5, it is around 9.8 by 5, around 2 seconds. So option number second is the correct answer. Answer number 2, second option is the correct option. The question number 23, a disc rolls on a table without slipping, then the fraction of its kinetic energy which is rotational is. So first option here 3, second option 1 by 3, third option 2, and the fourth option none of these. Now see how to do this problem. See, this is here the disc, and this disc is having some velocity as well as angular velocity. It is rolling. So for rolling, V is equal to R omega. So they are asking the fraction of rotational kinetic energy. So it means we have to find K rotational by K rotational plus K translational. So this we can say 1 by 1 plus K translational by K rotational. This we have to find. See, K translational your half mv square, K rotational your half I omega square, and I, since this is your disc, I is your moment of inertia, mr square by 2, and omega is your v square by r square. The K rotational will be your 1 by 4 mv square. So now then 1 by 1 plus kt by kr is equal to 1 by 1 plus kt by kr. mv square cancel, 1 by 2 by 1 by 4. This will be your 1 by 2 plus 1 by 4. So this is your 2. So finally answer your 1 by 3. So our option number your third, option in which 1 by 3 of given, that is the option number 2 is the correct option. Now question number 24. Question is given as a solid cylinder slides down and second rolls down an inclined plane, then the ratio of acceleration in the two cases. In the first option 2 by 3, second option 3 by 2, third 7 by 2 and fourth is 3. Now see the correct option and solution of that. So here cylinder is given. Let theta is the inclined plane. This is your cylinder. So when it is rolling, when it is slipping, so A is here G sin theta. Now in case of rolling, if it is your rolling, see the condition how to solve. Okay, mg sin theta acting here, so your friction force is there. That friction plays both the role, rotation as well as translational. The mg sin theta minus f is your m a dash. This is equation for translational motion. Second for torque, F r your I alpha, F r I is, since this is your disc cylinder, moment of inertia mr square by 2 into alpha. F is your m r alpha a tangential. Second, as this equation comes for rolling, a dash is equal to your r alpha. So F value we are substituting here, then mg sin theta is equal to your 3 by 2 m a dash. So a dash is 2g sin theta by 3. So a dash is the acceleration when it is rolling, while a is the acceleration when it is slipping. So you have to find the relation between the slipping and rolling. So a by a dash, g sin theta by 2g sin theta by 3. So a by a dash will be 3 by 2. So correct option your option number 2. So answer 2 is the correct answer. Now question number 25. Question is given as a solid metal ball of mass m is put at the top of the inclined plane attached to a curved track of radius nr, track of height nr, whose lower portion is in the shape of a circle of radius r as shown in the figure. Then find the velocity of the ball when it just rolls to the height r up to the point B. This is the problem, and the options are root over ngr, second option root over 10 by 7 gr into n minus 1, third option root over 5 by 7 gr n minus 1, and the fourth option root over 1 by 7 grn. See how to do this problem. Question is given like this. This is your inclined plane. Now from here, this height of the plane, and height of the plane is given nr, where r is the radius of this circular track, and a solid ball is coming here. So they are asking what is the velocity of the ball at point B. This is the question here. So we can use conservation of energy equation here. So initial potential energy mgh, h your nr, is equal to here kinetic energy and potential energy. The potential energy, this height your r, mgr plus half I omega square plus half mv square. Then we can write in this form: half moment of inertia of the ball 2 by 5 mr square, and omega square is your v by r square plus half m v square, as we can write for rolling v is equal to r omega. Then simplify mgr into n times. Then we can bring this in that side. N minus 1 mgr is equal to here 1 by 2, check it, mv square you can take common, r square cancel, 1 by 2 mv square. This will be your 2 by 5 plus 1. So m and m cancel here. So v is equal to, check it here, 7 by 5. This is your 7 by 5, 7 by 10. So v is equal to root over 7 by 10 n minus 1, m and m cancel, g into r. This is our option here. So see, from here we can get, see, half mv square. Further we can write 7 by 5, 7 by 10. Then the option will be your 10 by 7 root gr. So option number 2 is the correct option. So hence answer is your, answer number 2 is the correct answer. The question number 26 is given as: a hoop rolls over a horizontal surface without slipping with constant velocity v0. Find the velocity of point A of the hoop at the instant the line OA joining A with the center O makes an angle 2 theta with the vertical. That point velocity we have to find. So there are 4 options. Option number 1 is 2v. Option number 2 is 2v cos phi. Option number 3 v cos phi. Option number 4 v cos 2 phi. See the solution of this problem. As it is given, this is your hoop, and this hoop have velocity or v, and this is a point A, and this point have making an angle 2 theta with the vertical. So we want velocity of point A. Since it is rolling, v is equal to r omega for rolling condition, where omega is your in this direction. See, if we are talking about the velocity of point A, the one velocity is the translational velocity, another your tangential velocity v tangential, which is your r omega, which is your v. So right now, angle between these two velocity your 2 theta. So resultant velocity v is equal to your v square plus 2 v square cos 2 theta. So 2v square we can take common, 1 plus cos 2 theta. So 2v square 1 plus cos 2 theta, 2 cos square theta minus 1. So this will be your 2v cos theta. So resultant velocity of that point will be your 2v cos theta. So our correct option here, option number 2. So answer number 2 is the correct answer. Question number 27. The question is given: a solid sphere rolls up on inclined plane of inclination 30 degree. At the bottom of the incline, the sphere has a speed of 7 meter per second. How far will the sphere travel up the plane? First option is your 5 meter, second 6 meter, third 7 meter, and fourth is your 8 meter. Now see the solution of this. Incline have inclination 30 degree. Now here is sphere. This have velocity 7 meter per second. If right now if we are making a FVD here, normal force, mg sin theta and mg cos theta, and since this sphere is rolling, so it must have angular velocity omega. So first of all, as the sphere goes up, mg sin theta is acting your downward, that will decrease the velocity of the sphere. So friction force will act in the upward direction, and that friction force will try to maintain the velocity, but this decreases your omega. So first we will find what is the retardation of the center of mass. See, if I am writing the equation for this, mg sin theta minus f is equal to your ma, and f into r is equal to your I into alpha. I value 2 by 5 mr square into alpha. For rolling, f is equal to 2 by 5 ma, where a is equal to, right now we can write a is equal to your a tangential for rolling, so that the velocity of point of contact should not change. Now if I am putting this value, the mg sin theta is equal to your 1 plus 2 by 5 is 7 by 5 ma. So a is your 5 g sin theta by 7. This is the retardation it has. So now velocity 0. So v, and substitute the value, sin theta your 1 by 2. So this is your 25 by 7. Then v square is equal to u square plus 2as. V square initial 7 square, u square 0 plus 2, a is 25 by 7 into s. Now simplify, s is equal to your 7 square into 7 by 50. So this is approximately your 7 meter. This is the answer. So correct option is your option number 3. So answer is your option number 3 is the correct option. Question number 28. Question is given as: a disk of radius r spins on its own axis at a constant angular velocity and is gently lowered on a level floor. If the coefficient of friction is your mu, find the time that would elapse before pure rolling start. First option your t is equal to omega naught r by 3 mu g. Second option t is equal to your 1 by omega naught. Third option t is equal to omega naught r by g. Fourth option t is equal to 3 omega naught r by mu g. See the solution, how to solve this one. So as per the question here, a disk which is spinning with angular velocity omega naught, r is the radius. Now this kept gently on rough surface. As soon as it kept gently on a rough surface, see, the point of contact have tendency to move in the left side. Friction force will act in the right side. So that friction, what it does, this friction here gives some velocity as well as this changes omega. So if rolling starts, this is your intermediate state. At rolling, V must be equal to your r omega first. So see, what is the role of friction? This is your right now kinetic friction. F is equal to here. So one your mg, another your normal. F is your mu into N. So F is your mu mg, and that provide acceleration into mu into g. This is your second equation. So V. And for rolling, Fr is your I alpha. I is your moment of inertia. This is your disk, which is your mr square by 2. Mr square by 2 alpha. Fr. F your mu mg. Mu mg r is your mr square by 2 alpha. So alpha is your mr cancel. So 2 mu g by r. This is your alpha. So what is the role of alpha? Alpha will decrease omega and A will increase V. So V is equal to your u plus at. There was no initial velocity. U is 0. A is your here mu gt, and omega is your omega naught minus alpha, because this is your decreasing omega, minus alpha t. Alpha is your 2 mu g by r into t. This is your equation number 3. Now for rolling, from equation 1 and 2, check it. Mu gt is equal to your r omega. So r omega naught minus 2 mu gt. So t is equal to your r omega naught by 3 mu g. This is the time. So our option number 1 is the correct option, which is your omega naught r by 3 mu g t, 3 mu g. So correct option, your option number 1. The question number 29, the question is that a string of negligible thickness is wrapped several times around a cylinder kept on a ground horizontal surface. A man standing at a distance from the cylinder hold one end of the string. The man pulls the string so that the cylinder moves towards him. What length of string man must pull to bring the cylinder up to his hand? Now 4 options are given. Option number 1 is your L. Option number 2 is your 2L. Option number 3 is 3L. Option number 4 is 4L. See how to do this problem. So as per the question here, this is the cylinder, and from this end, let this is there, you can say position of man. The man is pulling right now. The distance of man with the center of the cylinder, your L. As we know, in case of rolling, for rolling, point of contact, if the center of mass have velocity v, if center of mass have velocity v, then topmost point should have velocity 2v. So if this point have velocity v, then this point must have velocity or 2v. So when the cylinder is coming from here to here, so center of the mass of the cylinder has to travel L distance. So how much the distance traveled by the topmost point? That should travel in a 2L distance, because velocity of that point here double. So man has to pull the string by length 2L. So our correct option here, answer number or option number 2, which is 2L. The question is given as a uniform circular disc of mass 200 gram and radius 4 centimeter is rotated about one of its diameter at an angular speed of 10 radian per second. Find the kinetic energy of the disc. First option 8 millijoule, second option 16 millijoule, third option 4 millijoule, and fourth option 0.8 millijoule. Now see how to do this problem. So in the question it is given this is the disc and this is the axis which is passing from its diameter, and it is given this disc is rotating about this axis with angular velocity 10 radian per second, and mass of the disc given 200 gram or 0.2 kg. So we have to find the kinetic energy of the disc. So kinetic energy is equal to half I omega square. About this axis, moment of inertia of the disc is mr square by 4. So radius of the disc is also given here 4 centimeter. So moment of inertia about this axis, moment of inertia mr square by 2. Then we can apply theorem of perpendicular axis. So this will be your mr square by 4 into omega square. Now we can substitute the value, half mass is your 0.2, r radius 4, the 16 into 10 power minus 4 in meter by 4, omega square means 100. Now simplify. When we are simplifying this, 2 into 4, 8, 2. This is 0.4 into 10 power minus 2. So we can say here 4, this is in joule, the 4 millijoule. This is the kinetic energy of the disc. So option number 3rd is the correct option. So hence answer number 3rd. This is the correct answer.